Okay. Okay. First, amines means how it will be. Like you know now, ammonia you know now, NH3. From this, you remove one hydrogen and replace alkyl group or NH2. So this is called primary amine. What is this? Remove two hydrogens, replace alkyl groups, two alkyl groups, secondary amine. Next, or remove all three hydrogens, this is tertiary. This is clear. Okay. Now, with same molecular formula, primary amine, secondary amine, tertiary amines are what type of isomers? Functional group isomers. What they are? For example, I am giving you something like this. C4 H9 NH2. Like that, like this I am giving a formula. With this formula, it can be a primary one, it can be a secondary one, it can be a tertiary one with this chemical formula. Now what is the relation between primary, secondary, tertiary, they will ask. So what is the relation I am saying? Functional group isomers. Primary, secondary, tertiary amines are what? Functional group isomers to each other. Now what is their chemical properties? Here you can say. Amines show basic nature. What they show? Basic nature. Because of presence of lone pair electrons, electron pair donor. Can we say Lewis basis? Yes. So amines are what? Lewis basis, or they show basic nature. Okay. It means what does it mean? When you place these amines like amines or ammonia in water, what happens is they will take, using this lone pair, they will take H plus ion from here. So if they take H plus ion, what is the remaining part? See, it becomes R, NH2 already there, one hydrogen is taken, so it will be plus charge. From this OH minus, see OH minus is forming now, so the resultant solution becomes what? Basic. What happens to resultant water, that solution? Basic upon adding amines. Okay, is this clear everyone? Okay. Now they will ask what is the basic nature of primary, secondary, tertiary, which is more basic they will ask. Okay, so for this I am taking simple examples, just follow me. CH3 NH2 CH3 NH CH3 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 CH3, like this we can write. Okay. I am just generalizing these groups as R groups, like alkyl groups. It can be any alkyl group. Now tell me, this is primary, secondary, tertiary. Now they will ask which is more basic out of these three, they will ask. Okay. See, in gas phase, in which phase? Gas phase. It should be 3, 2, 1. Which degree amine is more basic in gas phase? Tertiary. Now they will ask you aqueous phase. In which phase? Aqueous phase. If no phase is mentioned, consider as aqueous phase. Okay? Aqueous phase. So in aqueous phase means basic nature depends on availability of lone pair electrons as well as what type of groups attached here. What type of groups attached here and what is the solvent used here. Aqueous means water, na? So there will be effect of solvent and effect of these alkyl groups. So together considering, we are going to get an order like this. If these alkyl groups are methyl groups, what I am saying, if these alkyl groups are specifically methyls, if R is equals to what I am saying, methyls, then what will be the scenario? If R group is methyl, then answer will be 2 degree, 1 degree, 3 degree. This is the basic nature. When it will be the order? If these alkyl groups are methyls in aqueous medium. Okay. Now if alkyl groups are something like ethyls, what I am saying, alkyl groups are what? Ethyls. Then this order becomes 2 degree, 3 degree, 1 degree. Do you got the difference? In aqueous phase, what are the deciding factors? Two deciding factors. One is this electron releasing groups, and this solvent. Solvent means water, we are taking aqueous medium means. So there are two effects. One is electron releasing effect and one more is solvent effect. Solvent effect means it will show hydrogen bond. So due to this reason, the basic nature order is changing here. Okay, so if R group is methyl, what is the order of basic nature? 2 degree, 1 degree, 3 degree, 2, 1, 3. If R is ethyl, 2 degree, 3 degree, 1 degree. Just remember this. You may see this question in the final exam or somewhere else. Okay, next. Now I am comparing an aliphatic amine. What I am doing? I am comparing aliphatic amine. Aliphatic means R group should be like alkyl groups, like methyl, ethyl, propyl, butyl, like that. Cyclic ring also maybe, like this also. Tell me, is this aromatic ring? Is this aromatic? All carbons are sp3, right? So is there any pi bond to delocalize? No. It means this can be considered as aliphatic chain. So now aliphatic amines, and this is aromatic amine. Check whether this is aromatic amine or not. Yeah. So if it is aromatic amine, lone pair electrons are in conjugation now. Okay. See, basic nature is simple now. Basic nature means if the lone pair electrons are available to accept a proton, that will be more basic. What I am saying? If lone pair electrons are available to accept a proton, that will be more basic. Now tell me, in which case lone pair electrons are freely available? See, do we have any conjugation here like this? Do we have any alternate bonds like this? No. If there is any alternate bond, they are less available to accept this proton. Why they are less available? Because they are in conjugation. If there is no such conjugation, they are freely available to take the proton. Yes or no? Now see, in case of aniline, like aromatic amines, the lone pair electrons are in conjugation. See, like this, it is involving in the conjugation with this ring pi electrons. Yes or no? So tell me, in which case electrons are freely available? In aliphatic amines. That's why just remind a blind statement. Always aliphatic amines are more basic than aromatic amines. What are the? Aliphatic amines are more basic than amines. Okay, is this clear everyone? Okay, now look at this, what I am writing. A, B, C. So which is more basic, they will ask here. Why A? No conjugation. Perfect answer. In second compound, conjugation is there with one pi bond. In third compound, conjugation is there with two pi bonds. It means more conjugation. If more conjugation, less available, less basic. So you got the concept now? So what is the answer? A, B, C. So they may ask you about basic nature order, or they may ask you about KB order, they may ask you about PKB order. So what will be the relation between this? Basic nature directly proportional to KB, and that is inversely proportional to PKB. Remember this. Okay, done with this everyone? Yeah, perfect. So now preparation of amines. What we are doing now? Preparation of amines. Okay, two methods are there. First one is called Hoffmann's ammonolysis. What is it? Hoffmann's. Even if you don't remember the name also, it's fine. Just look at here. What I am doing is, I am treating ammonia. What I am doing? Ammonia with alkyl halide. With what I am treating? Alkyl halide. See, halide ion, we know it's an electronegative atom goes out. What is the charge creating on this place? Then this ammonia will be attacking here. So that what happens here? R, N, H. 3 means plus charge will get, remove that H. So that you will get RNH2. So this is called primary amine. Na? Okay. Now see, only hydrogens are there here. Now here alkyl group is there. We know alkyl group is releasing group. So it releases electrons Now tell me, which is more nucleophilic? Ammonia is more nucleophilic or amine is more nucleophilic? Amine is more nucleophilic because presence of this electron releasing group. That's why once after forming primary amine, now this will become more reactive with alkyl halide when I compare with the ammonia. So now what happens? This will again react with alkyl halide. What will be the product? R, N, R, H. What is happening? These lone pairs will take this one, it goes out, remove one hydrogen, you will get a secondary amine. Now tell me how many alkyl groups are there? So now which is more nucleophilic now? This one, because 2 electron releasing group. So now with this alkyl halide, who will react more easily? This one. So reaction keep on continuing up to formation of C, N, R, R, like this you got. Again, now tell me out of this which is more nucleophilic? Again this will react with Rx, finally gives you this lone pair also occupied, R, 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 R. So quaternary ammonium is formed finally. So what will be the major product here? This will be the product. Okay. So during Hoffmann's ammonolysis, what happens? Ammonia is treated with alkyl halides, gives you primary amine. Now primary amine is more reactive with alkyl halide, gives you secondary ion won't secondary amine won't stop there itself, further react with alkyl halides, gives you tertiary. Now tertiary is more nucleophilic, further react with alkyl halides to give you quaternary. After this there is no reactive site now. Nitrogen can make maximum of 4 bonds, all 4 bonds are occupied. So here reaction will be stopped. Okay, it means you just tell me, is it a good method for preparation of primary amine? I want to stop the reaction after primary amine. Will it stop there? Major multiple byproducts are there. Okay, this is the method, but not the best method. Right? Next one. This is most important. What is that name? Gabriel thalamide synthesis. What is it? Gabriel thalamide synthesis. So just listen to me what I am saying. Gabriel thalamide synthesis is for preparation of primary amines. For which amines? Have you seen this reaction for your IP exams? No. Okay. So Gabriel thalamide synthesis means, just see what I am taking, alkyl halides. Here also what we are taking? Alkyl halides. CH2X. Now this thalamide means this one. So this is called thalamide. What is this? Once again I am writing just to avoid all these lines. First benzene ring. See, maybe in the reaction, in the question they won't give directly, they will give like this, they will give like this, and they will give you reaction with ammonia. So now what happens is this OH and one hydrogen, this OH another hydrogen, remove them as water molecules, what else remaining? NH is remaining. So can I connect it like this? NH like this. Do you got what I am doing? Yeah. Okay. So this one treated with primary like alkyl halide. What is this? Alkyl halides. Now reaction takes place in basic medium like KOH like this. See, what is the medium I am using? Basic medium. First of all, I will tell you the product. Nothing else. First I will tell you the product, then I will tell you the mechanism. Alkyl halide is there now. Just remove this halogen from here. Nitrogen atom is there now here. Give to that carbon. What will be the product now? R, CH2, NH, like amine I am saying NH2. This must be which type of amine? Primary amine. Best method for preparation of primary amines. Okay. Now you got the product now? It's very simple. So now what mechanism happens here actually? OH minus KOH we are taking now. So that first we will take this proton. Okay, after taking, tell me what is there. N minus K plus potassium thalamide. What is the name of this? Potassium thalamide. See, negative charge is there, RCH2 group is there, and X is there. See, X goes out as a halide ion, so N minus is given here. What happens? This big ring as it is, you write NCH2R. That's it now. You are adding N to this carbon. That's it. Okay. Next, you hydrolyze this. Hydrolyze this means previously what I did here to formation of NH means I removed water. If you remember from ammonia, give that water back. It means OH this side, H this side, OH this side, H this side. So what is remaining part? R, CH2, NH2. Sir, we don't want anything about mechanism means what I told you. If the given alkyl halide is there now, remove that halide ion, give this nitrogen to there. That's it. That is your answer. Okay. Now they will ask what is the mechanism involved here. You should say it as SN2 mechanism. What is the mechanism? SN2. See, primary like alkyl halide is involved. This is a nucleophile attacking here. So what is the mechanism? One nucleophile is substituting another nucleophile. What is that mechanism? SN2. Now there are some limitations in SN2 reaction. It means, for example, what are the limitations we discussed there? Like for example, I have like this CH2Cl and I have Cl. Which of these will react will show the like substitution reaction, nucleophilic substitution? A or B? Only A or both? Or only B? Only A. Why only A? Because this is aryl halide, lone pairs are in conjugation, so chlorine won't comes out, we discussed. Here it is benzyl halide, chlorine can come out, now another nucleophile enter here, right now. So it means we cannot able to prepare. See, if this chlorine is not coming out means, look at this, if this halogen is not coming out means how this nitrogen will be attacking here. So it means if this chlorine is not coming out, so how can I prepare this compound? We cannot prepare this type of compound because if chlorine comes out, then only I can insert this NH2. So we cannot prepare aniline using Gabriel thalamide synthesis. This is a primary amine, but can we prepare this primary amine? No. Do you got everyone? Okay. Next, can I prepare? From this you tell me what type of product formed in Gabriel thalamide synthesis? Just what I told you, remove X, add NH2. So what is the product formed? CH2, NH2. That's it. This is your answer. Okay. Similarly, array, simple. Whenever there is a halogen on sp2 carbon, what I am saying, whenever halogen is on sp2 carbon, substitution won't take place. Here what is the hybridization? sp2. sp2 carbon paina halogen unte akkada substitution jarugutada, nucleophilic substitution jaragadu. So what about this carbon hybridization? sp3. Yes, here it is taking place. Now tell me in these two compounds, chlorine, chlorine, in which compound this Gabriel thalamide reaction takes place? A or B? A. Why A? Because this is allylic system, see this is sp3 carbon, so chlorine goes out, positive charge can be stabilized by this one. So what is the product formed in the Gabriel thalamide synthesis? NH2. What about this condition? Here it is sp2 now, vinyl halides, no substitution because these are in conjugation. Okay, so no product in Gabriel thalamide synthesis or in substitution reaction. Clear with these examples or any confusions? Okay, right. Next one. Okay, from preparation from amides. From where? Amides. Amides means it will be like this. Okay, one of the very important reaction again. This is called Hoffmann bromamide degradation. Name only this much big, but reaction is very easy. Degradation. Okay. this is amide na. Amide, you just treat this with halogens, like hex 2 means I can simply mention it as Br2 NaOH. What is the condition? Amides with Br2 NaOH. This mixture can also be indicated like NaOBr. How it will be indicated? So now what you need to do is just remove this C double bond O from the compound. What is the remaining fragment we have, tell me? RNH2. That's it. This is your answer. Okay? Right. Now tell me for this. So this is called aniline. What is this? Aniline. Everyone? Okay. I'm not explaining mechanism. If you see mechanism, you will really scare. So that's why I'm giving directly answer. I mean reaction, single step. Okay. Now here, during this reaction, intermediate they will ask. What they will ask? Intermediate. Alkyl isocyanate. What is the intermediate? Alkyl isocyanate is the intermediate. In Hoffmann bromamide degradation, what is the intermediate? Alkyl isocyanate. Now if you observe, product having one carbon less than the reactant. See, this CO group is removed. It means one carbon. If there is n carbons here, here it will be n minus 1c carbon. See, this kind of questions you are seeing in EAPCET exams. Previously I have shown you decarboxylation reaction also. You are removing CO2 means if there is n carbons this side, that becomes n minus 1. Here in this reaction also, if there is n carbons this side, n minus 1 in the product side. Okay. So what this method will do? It is again useful for preparation of primary amines only. What amines? Primary amines. From where we can prepare this primary amines? Amides. Amides to amines conversion. Okay, remember this. Now, okay, look at this. Reduction of cyanides. Yesterday we have made one table for reduction table we made. So there we have seen something like lithium aluminium hydride. So if you treat cyanides with lithium aluminium hydride, with what? Lithium aluminium hydride, converts into amines like R, same number of carbons, CH2, NH2, like this you will get. Cyanides will gives you primary amines upon reduction. What it will gives you? Primary amine. Cyanides upon reduction gives you what? With what? Lithium aluminium hydride. Now I am taking isocyanides. Isocyanides means this is cyanide na. Iso means you put NC. Okay. Now same reduction I am doing. Lithium aluminium hydride only. See, nitrogen is between two carbons na. This side one carbon, this side one carbon. Same reduction takes place. Okay. How many carbons are there on the nitrogen? How many carbons are there? This side one alkyl group means one carbon, one more this side. Here only one carbon is attached directly to the nitrogen. So that's why we got primary. Isocyanates gives you secondary amines. Remember that. R, N, H, CH3 like this. So alkyl isocyanates gives you what? Secondary. Nice. Next one. Let's move forward. Are you able to see what they are asking? Fast. Increasing order of basic nature. Before explaining this, just tell me, all of them are aromatic or aliphatic? Aromatic amines like aniline or their derivatives like that we have. Now, if I compare them with aliphatic, definitely aliphatic will be more basic. Now, within the aromatic compounds, basic nature, how we will decide? When I say that acidic nature, be electron withdrawing group. Basic nature? So now tell me, where do we have releasing group? Methoxy group releasing only now. So it will be more basic. A is highest basic out of this. Least basic is which one? NO2 is there. So least is 2. In between these two, A 4 3 2. That's it. Everyone got this? Yeah. Next. Okay. See, phenol, from phenol upon treating with ammonia in presence of what? ZnCl2. So what is the product formed here? Aniline. Once again, phenol with ammonia ZnCl2. What is the product formed? Aniline. Okay. Now, okay, look at this reaction of aniline. So tell me, aniline means nitrogen with what? Lone pair electrons on it. Like this, na? Nitrogen with lone pair electrons. So tell me whether it is ring activating or deactivating. Activating. If it is activating, nitration I am saying. Nitration means like HNO3 we are adding. So this HNO3 generates an electrophile NO2 plus. What is the electrophile in nitration reactions? In sulfonation reactions, it will be SO3. What is electrophile in sulfonation? SO3. Okay, now here I am talking only about nitration. So during the nitration, see, generally if I add any electrophile, where it will direct, tell me? Activating or deactivating? Forget about that. You just tell me what is the concept you know based on that. Activating the ring means electron density will be more at ortho and para position. Therefore, electrophile directs to which position? Ortho or para. Why? Because their negative charges are orthos and ortho and para position. Therefore, electrophile also goes to this like positive, negative, no? So that positions only we will observe. So that the final product expected to be like this: NH2, either here electrophile or at where? Para, or at all the positions, or at here. Like this we may expect. Ide kada jarigedi? Okay. Nice. Okay, now look at this. When I do nitration, what I am doing? So during this nitration means what is this nitric acid now? H plus ion it will provide. Acid only now, what it will provide? H plus. So that H plus ion is taken by the lone pairs first. Now what happened to that now, tell me? NH2 becomes now NH3 because lone pairs are taken by this one. So you write positive charge. Previously it is a ring activating group. Yes or no? Now what about this? Now nitrogen with positive charge. Do we have any lone pairs to activate the ring? No. So now it becomes ring deactivating. What it becomes? Deactivating. That's where during nitration the products observed is something like this. Para product is 51%. Meta product should not be formed like this actually means. But here how much it is forming? 47. And ortho product is how much? Generally what we know, if there is NH2 activating group means electrophile should goes to either ortho, para. These are should be the major products. But nitration of aniline giving what type of product? Para has 51%, meta has 47, ortho just 2%. Remember that ratios also very important. We can directly expect from here itself. Okay, para once again 51, meta 47, ortho 2%. There is a question on this previously. Okay. Done up to here? Okay. Next. Okay, listen here. They will give like this. So what is the first product? Tell me. A. What to do? Br to NaOH. Just now we discussed. What happens? Removal of? What is the name of that reaction I told you? Hoffmann bromamide degradation. So A will be CO, remove that. Aniline is your A. Okay. Now this one treating with NaNO to HCl. One of the very important fragment, this reaction from here to here, whatever you are seeing. See, I can say again, without this combination, there are very, very less chances to ask a question. Make a question paper. Okay. So now what happening here? N2, NH2 converting into what? NaNO2 HCl. So if you see this combination, what makes it to be? So this NH2 is there, na? Converts into diazonium chloride, like N2 plus Cl minus. What is happening? N2 plus Cl minus. Now again tell me, aniline upon treating with NaNO2 HCl gives us diazonium chloride. So it can be anything. Now you can see R NH2 I am writing. Now you are treating this with NaNO2 HCl. What will be the product? R N2 plus Cl minus. Remember this. Okay. So we can call this process diazotization. What is it? Diazotization or diazonium chloride is formed. Okay, with benzene ring, na? Benzene diazonium chloride you can say. Okay, right. So now why I am saying this is what much important means, from here we can have very different number of reactions. See what I am doing. If I treat this with CuCl, with what I am treating? CuCl, like HCl, like that they will take. Just remove N2 gas from here. See, we know N2 gas is very stable gas, nitrogen gas. So now upon heating, this is an unstable compound actually. What I am saying, this is a less stable compound. If this is a less stable compound, then preparation of other compounds from here is easy. So aniline first converted into diazonium chloride. So diazonium chloride will be treated with CuCl. So here Cl minus is there now. So if I am heating, N2 gas comes out. In the place of N2, now what will enter? Chlorine. So your answer will be chlorobenzene. If it is CuBr, HBr, like that. So next Cu2Br2, they will mention like this. What will be the answer? Okay. So now what will be the product? Okay. So here this reaction is called Gutterman reaction. What is it? Gutterman reaction. This reaction is called Sandmeyer reaction. Telusu kada? Okay. Now I am treating this with HbF4. With what? HbF4. Tell me what is the product? Fluorine is there now? Fluorine comes here. So it becomes fluorobenzene. This reaction is called, say something. Okay. Ball-Siemens reaction. What is that? Ball-Siemens reaction. Okay, Ball-Siemens reaction, you can see that. Next one, wait. Last one, CuI. What I am writing? Iodobenzene. Okay, next. This is done now? Okay. So from same diazonium chloride only, if they are treating this with H3PO2, with what? H3PO2. So H3PO2 produces, and it means it releases hydride ion. What it is giving? So in the place of N2 now who will enter? H minus. If it is H minus, so what will be the answer? Benzene with hydrogen means simple benzene only. So important reaction this is. Okay. Done with this, everyone? Okay. See, everything is there here. See here, Cu, Cl, Cu, Br, if we use, what we should say? Sandmate. If I use copper metal with HCl, you should say gutterman. So if I use Ki or Cui, what is that called? Like normally iodobenzene. Iodide ion will be there, iodobenzene. If I use this HbF4 or ASF6, fluorobenzene will get, this reaction is called what? Ball-Schieman's reaction. That's it. Next one, KCN means Cn minus, na? CuCN, KCN means Cn minus, so cyanide minus in the place of. If I use H3PO2, benzene. If I use water, OH will enter. Phenol will be the answer. Okay, like this. Okay. If I use aniline only, in the last class I told you about dyes, colors of our cloths I told you. Do you remember? Okay, that I did with phenol. Here I am saying with aniline. So aniline will activate at this para position. So you add this nitrogens at the para position. See, aniline at para position, N double bond, benzene. So what is its color? Yellow color dye. Okay, reaction takes place in which medium? Acidic medium. So pH they will say, pH should be greater than 7 or less than 7. Particularly around some 4 or 4.5 for this reaction. Okay, that's it. Next. Tell me for this, what is your answer? Many mistakes are there, I will correct them anyways. HNO2 is there. Previously what I told you, NaNO2, HCl. This is also mentioned as H plus NO2 minus. It means HNO2. Now tell me what happens. NH2 is there, this one is there. What comes out? Okay. CH3, CH2, NH2 is there now. If it read this with this, what happens? I told you there. N2, N2, yes, perfect. N2 plus Cl minus. With HNO2 means it also releases H2 or OH minus. So if it is going out, what will comes in? OH. So ethyl alcohol will be produced. Ethyl alcohol with SOCl2. Alcohols with thionyl chloride. This one, alcohols with thionyl chloride. What happens, tell me? SOClCl. See, like this, OH goes out as SO2, so chlorine comes here, so it will be CH3, CH2, Cl. So this H and one more Cl forms HCl. This is the best method for preparation of alkyl chlorides. Alcohols converts into alkyl chlorides using thionyl chloride. This is the best method for preparation of alkyl chlorides, I told you, because SO2 and HCl are, both of them are gases, so they can be removed out easily. Okay, next. Treating this with ammonia. What happens? Ammonia to treat the same method. This comes out now. So what is the product formed? That's it. This is your answer. Ethanamine. Where do we have? Okay. Next one. One last reaction, ma. I don't want to take more time. So carbyl amine test. Carbyl amine reaction. What is this? Carbyl amine. Please listen here. Anyone studied about this carbyl amine reaction? 2 marks question, na? What happens? Tell me. Once again. Vinandi. All primary amines. What I am saying? All primary amines with chloroform. What I am saying, that must be which one? Not only aniline. Any primary amine react with what? Forms alkyl isocyanates. For example, this is primary amine RNH2. Chloroform means this carbon, this nitrogen forms RNC. So what is this? Alkyl isocyanide. So it has a very foul smell. Using that smell we can identify the given compound might be primary amine. So now they will give you 4 options. Here I am saying ethanamine, just imagine the structure. Ethanamine, aniline, next N-dimethylamine. Are you able to imagine N-dimethylamine? So tell me, out of these 3 compounds, which will shows carbylamine test? Multiple answers. Ethanamine is primary amine or not? Yes. Next one, second one, what I told you? Aniline also primary amine only, no? That will also show. Third one, what I told you? N-dimethyl amine I told you. N-dimethyl means a nitrogen 2 methyl groups are there. So is it primary or secondary or tertiary? So will it show? No. So just identify whether the given compound is primary or not. If it is primary amine, that will show carbylamine test. That's it, over. Okay, and the next one. 1 minute. Alright, first one, IUPAC nomenclature. Everyone? I mean structure, I am saying just IUPAC nomenclature, everyone?